Okay, today we are going to be talking about more rational and irrational numbers. The whole goal of today is to be able to take rational numbers and plot them on a number line. We're going to use a lot of what we did yesterday with intervals and finding our appropriate intervals to get those plotted on the number line. So let's go ahead and start. Example number one, we're going to plot the rational number on the number line. The rational number they give us is 3/4. So now we look at this number line, and we're going to try to find where does 3/4 fit on this number line. Is it going to be in the 0, 1/2, bigger than 1, less than 1? Where exactly is this going to go? What I would recommend is converting these to a decimal. So if we look at 3/4 and we convert it to a decimal, we see that by typing in 3 divided by 4, it equals 0.75. And so now we're going to go through and convert our fractions into decimals, and we're going to say 1/2, 1 divided by 2 is 0.5. 1 and 1/2, 1 divided by 2 plus that whole will give us 1.5. 2 is going to stay there as 2.0. And then here we're going to have 1 divided by 2 to give us 0.5 plus our whole is 2.5. So now we're trying to find where does 0.75 fit. And so if we start over here, we're kind of asking ourselves, is it going to be bigger than a half or less than a half? We know that 0.75 is already less than 1, so it's got to be somewhere in this range here. And so we can compare and use our ability to compare decimals, 0.5 and 0.75. And when we compare them, we ask ourselves, which is bigger, 0 or 0? And we can tell ourselves neither. And which is bigger, 5 or 7? And 7 is definitely bigger. So that means that 3/4 is bigger than 1/2. So it's going to go in here. In fact, 3/4 is halfway in between 1/2 and 1. So we find that, we put our point on the number line, write our 3/4 above it, and call it good. Let's try another example. This one is 0.2 repeating. It is a rational number because it is repeating. And we're going to ask ourselves, where on this number line does it fit? Now this time, they don't have all of our intervals labeled, so that's the first thing we need to do. So I noticed that between 0 and 1, it's split into 3 groups. Since it's split into 3 groups, I know those groups are going to be thirds. This would be our first third, our second third, and finally this is our third third, or just 1. Over here we're going to have 1 and 1/3, 1 and 2/3, and then finally 2. So 0.2, well, if we convert these to decimals, 1 divided by 3 gives us 0.3 repeating. 2 divided by 3 gives us 0.6 repeating. Now we can obviously see that 0.2 is going to fall in between 0 and 0.3 repeating, and it's going to be not as quite as close to the 0.3, so I'm going to put it right about there and label it as 0.2 repeating. I was now able to graph 0.2 repeating on the number line correctly, even when I was missing some of the intervals. Example number 3, we have the square root of 16. Well, the square root of 16, if we type in second square root 16 and then hit enter, we find out that that actually equals 4. So now we're really trying to just graph 4 on this number line. Well, again, we are missing intervals, so we start to try to figure out the value of each interval. We notice that between 0 and 10, there's 1, 2, 3, 4, 5 groups, which means this is going to be split into 5 sections. When I take 10 divided by 5, I notice that it equals 2. So each interval then has to be worth an additional 2. So if we start at 0, we're going to get our next interval to be 2. We add another 2, we get 4. Add another 2, 6, and then finally 8. See if I can get these to move up. Okay. Now we need to find where the square root of 16, which is equal to 4, will go. I'm going to do that in green. This will go exactly right here. I'm going to write square root of 16 above it, and that's how we graph it. And finally, our last example, 3.625. We're splitting these up into, or between 3 and 4, we've got to find our intervals. It's split into 1, 2, 3, 4 groups. So we need to split this whole that's here into 4 groups. So if we take 1 divided by 4, we get 1/4, but most importantly, let's put it in decimal form of 0.25. And the reason why we put it in decimal is because the original rational number they give us is as a decimal, so it's going to be a little bit more helpful for us. So now we have 3.25. We add another 0.25 here to get 3.5. Add another 0.25 to get the next one. We get 3.75, and then finally 4. Then we add another one to get 4.25, followed by 4.5. I'm going to erase these pluses so we don't need to look at those anymore. We're now going to take this number and graph it in green, 3.625. When we compare it to 3.5, it's a little bit bigger. So we're going to go just a little bit bigger than that. We're going to put a point here and label it 3.625. Okay, that was our final example. I hope that helped on plotting rational numbers on number lines and finding the intervals. Here in a couple days, we will plot irrational numbers on number lines.